The break-even point formula is very well used and very commonly used, and it tells us the number of units it takes to break even. For example, how many doctor's visits must be done every month in order for the office, the practice, to break even, or how many car washes we need to wash before we get our investment back. Well, the question could be asked differently. In this case, what is the selling point? Should we set the selling point in order to break even, knowing what our fixed costs are, what the break even point is in the number of units, and our variable costs? This could be a competitive analysis scenario done before someone decides to invest. For example, if we know that the competition is selling a car wash for $20, can we compete with that? So we have to assume a certain selling price, and it becomes very important to compute it. So let's take a look at a scenario of a car wash where we know the variables and we put them in this area, the yellow highlighted cells. What is unknown is how much should we charge per car wash to break even according to the data that we have in the yellow highlighted cells. Well, in algebra, we know that we can rearrange a formula as long as we maintain the equality integrity. In other words, what's on the right side must always be equal to what's on the left side. So we take the basic formula A and we change it to B by simply taking the denominator, selling price minus variable costs, and bring it up and take down the break even point in units below it. This formula becomes very easy to rearrange one more time, where we keep the selling price on the left hand side and we move the variable costs to the right hand side. Now, you know, in algebra, if you move a negative entity from one side to the other, it changes algebraic sum. So the negative variable costs, when we move them to the right hand side, they become positive. So in formula C, you'll notice that the selling price equals the fixed cost divided by the breakpoint in units plus the variable cost per unit. So apply that, and we look at the answer as equal our fixed cost, which is 1.2 million, divided by our break-even point, which is 120,000 car washes, and to that we add the variable cost, and the variable cost is $10, and hit enter, and the selling price should be $20. If you do the math, you'll find out that at $20 you will recover your initial investments after 120,000 washes.